In this video, we're going to find the derivatives of cosine and sine functions, and we're going to try to build a little bit of an intuitive understanding of how these functions' derivatives can be found. Now, to start out with, what does the derivative of any function tell you? Well, it tells you what its gradient is at any point of x. So we're going to focus on our sine graph here just for a moment. And you'll see here that I've drawn my sine function in red, and I've drawn my function here in red as well. And we're going to focus on finding the derivative of g of x first, just because it seems like a neat place to start. So let's take a look at what our derivative is of sine of x at various points of x. Let's start with this point over here. What is our gradient at that particular point? Well, if we take a look at our line over here, you'll see that it increases in x pretty much is exactly the same as in y. So it's reasonable to assume here, just for a minute, that the gradient at this particular point here is equal to 1. Okay, fair enough. We're going to look at just key points because in between it's a little bit more difficult, of course, to find what the gradients are. So for example, here, we're not really going to worry about it. We're just going to look at key points just for now. Now, if we keep following our sine curve, then you'll see just over here where we have x equals pi over 2, at this point here, what's going to be our gradient? Our gradient at this point is going to be 0, right? And, oops, you can't really see that. Let me just put that down here. Your gradient at this point is 0. Cool. So far, so good. Let's keep following our sine curve and look at the next key point. So over here, what's our gradient of this going to be? Well, if we assume that this was gradient m equals 1, then it's safe to assume that this one here is the opposite, right? Gradient m equals to negative 1. And then we can keep going, right? I mean, we've got our gradient over here again. We've got our gradient of m equals 0. Then over here, we've got a gradient of m equals 1 again. And so on. Now, one thing in particular that I want you to pay attention to is not just what our gradients are for our sine curve, but also notice how over here I've got my value of cosine of x at x equals 0 as 1. That is pretty curious. So let's try and draw a dotted line. Let me do that in a slightly different color. So let's write down what our value of cosine x is here. Well, our value of cosine x, well, that's just equal to 1 at this point. Okay, so that's here as well. Let's go ahead and go to the next key point. So we said the next key point is over here where m equals 0. And let's go and trace our value of of our cosine value, and you'll see that the value of cosine at that point is also y equals 0, just like our gradient. And we can keep going, right? So over here, we've got our gradient of negative 1. What's our value of cosine of that x value? Well, it turns out this value right here is negative 1, and so on. We keep going. We've got a value of 0 over here. We've got a value of 1 over here. That's not m, this is just the value 1. Okay, so let me just draw that again. Okay, now you can see, well, my gradient is always equal to what the cosine value is at that point. So is it then safe to assume that the gradient, or sorry, my derivative of my sine function is always just going to be cosine x? And indeed, you'll find that that is the case. If you find the derivative with respect to x of sine x, of sine of x, then that is always going to be equal to cosine x. Okay, so your derivative of sine x is just equal to cosine x based on these values that we have already found. Now, let's look at the reverse situation. Okay, so what if we now take this entire graph and we're going to look at it on this side over here. And now, instead of looking at sine of x, let's look at cosine of x. So let's follow cosine of x. That was our, let me just do that again. I'm running out of space here. We've got our function f of x equal to cosine x. Okay, let's go ahead and go through what our gradients are at each point. Well, over here we've got a gradient of 0. M equals to 0. Okay, fair enough. What's our gradient? What's our gradient at this point here? Well, at this point our gradient m equals to -1, right? And our gradient here equals to -1. Cool. What's our gradient here? Gradient m equals 0. Here our m equals to 1, and so on. We've got our value m here equals to 0 again. All right, let's look at our values of sine of x. So you'll see here my value of sine x at this point, we've got pretty much the reverse situation here, right? So we've got a value of 0 over here. 0, 0. Very, very similar to what we just saw earlier. Here we've got a gradient of -1, but what's the value of sine of x at this point? Well, the value of sine of x at this point here is just equal to 1. So we need to be a little bit careful. And you'll see here that the value of the gradient is just the reverse in this case, right? So let's keep going and see how that pans out. So again, we've got a value of 0 over here. I've got my dotted line over here like that. Here I've got a gradient of +1. My value of sine at this point here is -1. So again, is the reverse. And so on. My value of sine here is 0. So this is going to be my value of the sine of x function here. So now, based on all of this, it's very, very similar to how the sine function works, but we need to be a little bit careful because here the derivative of cosine x is not sine of x, but is just negative sine x. Okay, so here you can see 0, it doesn't really matter if it's positive or negative. -0 is the same as +0. And over here you can see my value of sine x is 1, my gradient is -1. Here my gradient is 0, 0, that's fine. Over here my gradient is 1, the value -1. So it's always the opposite of what your actual value is. So let's summarize what we have just found then. That means that my derivative d by dx of cosine x is just equal to negative sine x. And this is always the case. So I hope that you found that this was useful. Let me just tidy this part up as well. So this was negative sine x like that. And the other one, we write that again just to make it abundantly clear that we've got cosine of x in here. And then of course if you integrate, you can just go the other way, right? So if you wanted to say, for example, the integral of cosine x is sine x, the integral of negative sine x is cosine x, and so on. But we'll get into more detail once we get there. Okay.